Okay, and just like always, make sure you have tried the problems before you watch the examples worked out. And what I have are 1, 2, 3, 4, 5, 6, 7, 8, 9 different examples from your new assignment here. So we're going to go through each type here and give you some insight on how to work all the problems. Now what we're doing here is we're doing infinite geometric series. Convergence means that it has a sum. Divergence means it doesn't have a sum. It goes to infinity or negative infinity. So if you add like 1 plus 2 plus 4 plus 8 plus 16, where it's geometric and the ratio is 2, that's not going to have a sum. But if you add 1 plus 1/2 plus 1/4 plus 1/8 plus 1/16 and so on, where your ratio is a half, it does converge and it has a sum. And I can show you how. There's a nice little formula here. Now to determine if it converges or diverges, what you have to do is you have to take the absolute value of the ratio. If the absolute value of the ratio, so it could be positive, it could be negative, if it's between 0 and 1, it converges. If it's greater than 1, greater than or equal to 1, it diverges. It has an infinite sum of some type. So I'm looking here, I see two consecutive terms. It's already told me that it's infinite and geometric. So I take these two terms and I write the ratio. It's 135 over 405, which is 1/3. So the absolute value of 1/3 is between 0 and 1. I know this converges. And not only do I know it converges, I can use the following formula if it converges. Infinite geometric convergent. Doesn't do anything with arithmetic. Infinite geometric and converges by using the sum is equal to the first term all over 1 minus the ratio. That's simple. So my first term is 405. 1 minus my ratio. My ratio is 1/3. So this is 405 divided by 2/3, which is 405, times the reciprocal, which is 3/2. Well, it doesn't come out to be a nice neat integer, but that's okay. That would be 1215 over 2, or 607.5 if I didn't mess up. And that's what all those terms are going to add up to be. Even though it goes on forever and ever, that's the limit. That's what it turns out to be. Now this next example, all right, I find the r. R would be the second term over the first term. Uh-oh, that's no good. The absolute value of r is greater than or equal to 1. So this diverges, and since you're adding a bunch of positive numbers, this goes to positive infinity. All right, so this one converged, and the sum was 607.5. This one diverges, and it goes to positive infinity. That should cover you on those kinds of problems. If not, you can call me and ask me. Now it says here to evaluate each infinite geometric series described. Well, look at what I have. It's infinite, it's geometric, and the absolute value of the ratio here, r, the absolute value of negative 1/5 is 1/5. That's between 0 and 1. So this has a sum. And I go straight to this formula, which is another formula that you're going to need to memorize. Got to know this one. So the sum is the first term, negative 5, which they give me, all over 1 minus the ratio, which is negative 1/5. So that's negative 5. Subtracting a negative is like adding the opposite. So that's 6/5. So that's negative 5 over 1 times the reciprocal, which is 5 over 6. And I get negative 25/6 is my sum. Now if you want to write that as negative 4 and 1/6, that's okay. But if you punch it into your calculator, you're going to get a repeating decimal. I'm going to do the same thing here as I'm going to do here. Now look, this is what's being raised to the power in this summation notation. That's what makes it geometric. And look, the absolute value of this, the absolute value of negative 1/5 is 1/5, and that is between 0 and 1. So this thing converges and it has a sum. Now, I need the first term. I got r. Well, actually, I got r is equal to negative 1/5. Excuse me. This was the absolute value of r. I need the first term, so if I plug 1 into here, 1 minus 1 is 0, so negative 1/5 to the 0 is 1, times 4 is 4, so a sub 1 is 4. So my sum is 4, the a sub 1, over 1 minus r, over 1 minus negative 1/5. So what that means is I've got to do, just like the other ones, I've got to do the subtraction on the bottoms, like adding the opposite. So I have 4 over 6/5, which is 4 over 1 times the reciprocal, 5 over 6. You can simplify it a little bit. I get 10/3 or 3 1/3 if you want to. And that's what that adds up to be. And you say, well, that's weird that it adds up to be that. Well, it's alternating because it's going to go between positive and negative when the ratio is a negative number. But that's what it zooms in on, 3 1/3. Now this one says, write the first 5 terms of the sequence described. Well, the first 5 terms, a sub 0 is 1, a sub n is a sub n minus 1 plus 4. What they mean by that is that this is defined recursively. This says, this is the first term. They call it a sub 0, not a sub 1. This is the first term. So the second term, if that's a 2, or actually, if I'm looking for a sub 1, because that's a sub 0, if I'm looking for a sub 1, it's equal to a sub 1 minus 1, the previous term, plus 4. So a sub 1 is equal to 1 plus 4, which is 5. A sub 2 is equal to 5 plus 4, which is 9. A sub 3 is equal to 9 plus 4. You're adding 4 to the previous term to get the next term. And a sub 4 is equal to 13 plus 4, which is 17. So my first 5 terms are 1, 5, 9, 13, and 17. Unless, of course, your teacher decides for some bizarre reason not to count a sub 0. So I'll check his key here. And this was problem number 11. I am running behind. I've got a class starting up here in just a second. And he does not count this. He does not count this as his first term. So you've got to go one more. You've got to have a sub 5. So that would be 17 plus 4, which is 21. And I get rid of this. So he wants those as the first 5 terms. A sub 1 to a sub 5. Alright, so we're going to have to do that. Now we're starting with a sub 1 here at least. So notice that a sub 2 would be a sub 1 squared plus 2. So a sub 2 would be the previous term squared plus 2, that's 6. A sub 3 would be 6 squared plus 2. That would be 38. Oh, this is getting big in a hurry. A sub 4 would be 38 squared plus 2. Oh, 38 times 38. I don't know if I'm going to be able to do the next one. 4, 6, 30. What is that? 114? 114. So that's 4441. Yikes. So this is 1444 plus 2, or 1446. And I need one more, and I don't have my calculator, and I'm not wanting really to take this number times itself, because like as I mentioned, I'm hurting for time here. So I will look off the guy's sheet here, and that's 2090918. So that's a pretty good sized number. 2,090,918. So here are your first 5 terms. This one, this one, this one, this one, and this one. I'm going fast, I'm sorry. I got to teach a class in about 5 minutes here, and I still have 3 problems to do. Write an explicit rule and a recursive rule for the sequence. Alright, the explicit rule, notice that they give you R is 10. That means it's geometric. So the explicit rule, remember a sub n is equal to a sub 1, r to the n minus 1. So a sub 1 is negative 2, r is 10 to the n minus 1. And that is the explicit rule. Now the recursive rule says you've got to write the next rule in terms of it. So what happens here is you want to look for this pattern. By the way, I put a negative 2 there. That's an equal sign. That's a positive 2. Sorry about that. So if I plug 1 in, I get 2. If I plug 2 in, I get 20. If I plug 3 in, I get 200. Look at the pattern. Do what I did here. Write the first few terms so that you can see the pattern. You're multiplying by 10 each time. So a sub 1 is 2. A sub n is equal to whatever a sub 1, or the term before it, a sub n minus 1 is, times 10. Alright, and that would be, all of this would be the recursive. This is the explicit, this is the recursive. Over here, very similar, except that this is arithmetic because d is given here, so it has a common difference. Remember, for geometric, or for arithmetic, a sub n is equal to a sub 1 plus n minus 1 times d. So a sub n is equal to 3 plus n minus 1 times 10. So that's 10n minus 10. So I'm going to kind of cheat here and write it quickly, that a sub n is equal to 10n minus 7. So what's happening each time is that you're adding 10. So recursively, a sub 1 is 3, a sub n is equal to whatever the term is before that, a sub n minus 1, and then you add 10 to it. So this is the recursive, and this is the explicit right there. Then it says, write a recursive rule for the sequence. Well, they gave you the sequence, but they didn't give you information like is it geometric or is it arithmetic. But you can see it's arithmetic because it has a common difference. Look, second one minus first one, 6. Second one minus first one, or second one there, third one minus second one, excuse me, 6. 19 minus 13, 6. So my first term is 1 and my common difference is 6. So now I work it just like this guy. They want a recursive, you're adding 6 each time. A sub 1 is 1. And a sub n would be whatever the term is before that, a sub n minus 1. And then you add on the difference, 6. And this would be the recursive rule for the sequence. Now that's really fast. I didn't do any of the story problems, but this should get you started. I hope this helps. Give me a call if you have a question.